Hey, hello there, and welcome back to another video. So today is December 2nd, and that means it's the second day of Advent of Code. But before jumping into the second day puzzle, I want to revisit the yesterday's puzzle because I wasn't very happy with the solution that I got. Let's try to remember how the code looks like. Yeah, this mess. By the way, I think I should increase the font size. You may notice that I'm wearing glasses. In yesterday's video I wasn't, and I think I was crouching a lot to see the screen because I'm not used to using the laptop screen. I have another monitor here, but for recording that's not very useful, I think. But anyway, I think the font was a bit too small, so I was crouching a lot, and probably it's worse for the video because, you know, if anyone looks at this on a small screen, I guess it's better to have bigger font. Anyway, yeah, this beauty of code from yesterday, it's quite a mess. After the video, I went to the climbing gym and I was thinking about this thing, and I was like, oh man, I did so many things wrong. So, okay, we have part one, which is this, and part two, which is the rest. Part two has a lot of repetition too, but I want to first think about part one because it was simpler, and I think if we think about this in a clear way, we can then copy the same approach for part two, and it should also make part two like less messy. So let's remember a little bit. In part one, we had to find these two-digit numbers, taking the first and the last digit character from each of these lines. So this one would be 12, this would be 38, this would be 1 and 5, 15, and this would be 77. Well, this is the real input, and then we have another sample. Okay, all of that. So in the solution, we're iterating over each line, and to find the first digit, we are iterating over the characters of each line and finding the first character that is numeric. Well, and then falling back to 0. I said fall backing, and that is a very funny English error. I remember I had a colleague, work colleague that also wasn't English native, and she once said, instead of setting up, set-upping, and it cracked me up because it's I don't know, it's the kind of error that I think a native speaker probably doesn't do, but to someone who's not native, it just makes more sense. Anyway, okay, what we were doing, yes, we are extracting these things as characters, and then we are forming a string with those two characters, and then parsing that string, and all of this is just a gunk and a mess. In part two, I was doing something completely different, but in the end, I had the digits as actual numbers, so the final calculation is, I think, a little bit more clear, like multiplying the first number by 10 to have like a tens multiple, and then adding the last digits. So yeah, to form a two-digit number. And I think for part one, we can probably do this. And I think I added this unwrapper 0 because on the second sample there are some lines that don't even have a numeric character. So for part two you have to use the numbers words. So this would be 8 and 3. So that's why we have a fallback here. But I think the way that we are doing this, it would probably make more sense to do something else. Let's think. First of all, instead of doing this find and receiving a character here, I think we can do, instead of asking is numeric, I think we can do something like, no, digit, there was something, well, is digit and 2 digit. What does is digit do? Okay. It returns a bool. Okay. Yes, but we also have the 2 digit. You have to pass the base. This returns an option. Of course, the character might not be a digit. So if it's not, it doesn't return. It returns none. But with this, we can do, well, map to this and then find the one that is not none, but there is already an operation for that called find, if I can type, find map, which does exactly that. If these things return something, then find map will give you that something, otherwise it will give you none. And if we don't, well, here if we wanted to unwrap, we should unwrap at 0, and same thing here. Let's copy this approach over here. So if we do this, we at least can copy this approach, which is already, I think, an improvement. And this is complaining because these are, okay, U32, so 2 digits gives you back an unsigned 32, that's fine. Okay, so I think this is already a bit better than what we were doing, but I was also thinking, like, do we need to do this unwrap or 0? Because we could also, we could do something like, well, if the line doesn't have a character, a numeric character, we can just skip that line. And for that, we could use something like map, no, not map, how was it called? Filter map? Yes, filter map. Which is like a combination of filter and map. And here we need to say, okay, this is sum, so it's the result. But if any of these two things, I'm having a code, it's an unknown number, so how do I hang up? That's it. Where was I? So yeah, if any of these lines don't have a digit, I think we can just short circuit and use the question mark operator for that. Yeah, this becomes single one-liners. And that's fine, I think. Yeah, and I think this is already quite better than what we had before, right? Well, with this font size it's difficult to see, but yeah, previous code was much messier, and I think this looks better. I don't know if it actually works the same, so let's run cargo run. Yeah, thanks, fish. Oh, but Control F doesn't work in here. Control F is the shortcut for how to complete everything that you suggested. So if we run this, we get these numbers, which I don't remember if they were my answers. Advent of code. There's day 2. So my first answer was 55386. Yes, okay, yeah. We still have the same answers, that's fine. And this approach makes more sense. Also, let me look at the actual input. We have some long lines in here, but there's nothing like too long or anything. I'm also thinking, okay, this is already like an improvement. Let's add this. I'm also thinking, like, why are we doing this? Finding the first character and finding the last. We could maybe also just find all the characters, all the digits, and then grab the first one and the last one, maybe. Find map. Yeah, couldn't we do something like simply say digits would be this thing, find map, but then collect everything maybe into a vector, and then here say digits first, which of course give you an option, but we can short circuit that and then say digits last, same thing, and look at that, and collect is complaining because because I'm using find map. I meant to use filter map, right? Yes. So filter map is sorry, I think that I'm also using filter map here. Is this correct? Yeah, this I got confused a little bit, but yes, this is I think correct, and it should give the same answer, and it does. And I guess we could, instead of collecting, use an iterator for this, but this already, even though we are doing like extra allocations when we don't need to, while in the previous approach we weren't allocating anything. I mean, this is not a computationally complex problem or anything, so I don't care about doing this. And this already also looks better than before. It's a bit shorter. Yeah, just getting the digits and saying digits first and digits last. Awesome. I think the same approach could probably work for part 2. I'm thinking a bit ahead. But let's just try to express part 1 nicely. So yeah, this is also something that's of an improvement. Let's add this. I want to just see how this would look instead of using a vector, using a mutable iterator. And iterators don't have a first call, but we can just say next, I think. Oh, but this consumes the iterator. Yeah, I think this won't work. Let's see. No, it falls short by quite a while because for cases like this won't give you 77 because it will first consume, well, the first one, but then there won't be a last one because it's already consumed. So we would have to clone the iterator or something like that, and that doesn't sound very, very fun. I mean, we could do something like digits like this, and say something like reverse, just rev digits be the digits. I don't know if this consumes the thing. Let's see. And then here using the reverse digits. Yeah, but this is already moved, I think. Yes. So let's clone the thing, and this would, I think, give me back the correct answer. Yeah. But again, it's a bit more verbose, so I think I'm okay with vector solution for this. Yes. Okay. Good. So that would be part 1. And on part 2, what were we doing for part 2? We are first asking if it is numeric, then we do this off for parsing, which it can also, this is the same as doing character to digits. Yeah. Well, actually, well, this, yeah, and unwrapping that, but fine. This will go all the way. And then for checking, we have these names of the different numbers, or I guess, yeah, the names for the different numbers, the words corresponding to each number. Maybe I would want to call this number words. And then what we are doing is, for each position, yes, we're going from front of the string of each line to the back, and asking on each position I if there is a number word in there, in that position. And if it is, then we have found the first digit. That's an awful way of doing that, I think. I think we can do something quite similar to this. So yeah, we are going to do, first of all, do we need to do a filter map? I don't think so, but maybe that allows us to use some short-circuiting for options or something that might be useful. But let's try to do something similar to, yeah, let's try to do basically the same thing in here. Oh yes, we're going to have the digits. Yeah, I want to probably have the same idea of having the digits and then getting the first and last. So let's do here a filter map. And what I want to do is probably something like first try to convert this character to a digit, and if you can't, what do we want to do? Oh, I think I need also the position of the string. Sorry, the position of the character. Isn't there something? I think I could use an iterator here instead of doing line chars. Do from 0 to line length, and then have the index. But yeah, and then instead of using characters, I could use bytes. But I think strings do have something to get the indices. Char indices, match indices. What is this? Oh, interesting. Can I use this actually? Disjoint matches of a pattern, and I don't think I can use this because it's interesting. Like the standard library does have this pattern matching methods on strings, but the patterns are quite limited. There are basically whole strings, so in those cases it matches if that string is a substring of what you are matching it against, or arrays of characters and something else. I don't know if they allow whole functions, but they are limited, and I don't know if the regular expression package uses, like, defines new patterns based on regular expressions, something like that. It's something I have to investigate. But anyway, how was the other? Char indices, sorry. Yeah, the iterator yields tuples. The position is first and the char is second. That's good. That's awesome. Okay, so it gives you tuples with the position, the string, and the single character. That's great, because I think those are the two things that I need. So I'm getting confused by all this gunk code. Just comment it. I don't want to see it highlighted. So we have the index of the character and the character. So if the character is a digit, that's it. And here we can say, I think, or else is the method that we want. Yes, and or else we want to see is if at this position on the line there is one of these words. So we can say, what can we say? So this is the thing that I want to return the digit itself. So the digit is the index of the word in this array, or the index plus 1, because this starts at 1. Maybe I could add 0 here. Is 0 in this? No, it's not in the sample input, so I think there is no harm in putting 0 in here and not having to add 1, but maybe it's kind of the same. Well, let's add 1 and then see what happens. Okay, I missed my indentation because the auto formatter. So, or else, what do we want to do? We want to find the position on that array. So num words, it's not position. I have to iterate over this and say position. And if the line starting at I, so let's slice it there, starts with this word, then that's the position that we want, right? That's probably... So this position already gives us an option, but that's fine because or else expects a function that gives you back an option. So this is like chaining of option values. This is complaint because we expected an option of U32, but it got U size, of course, yes. So this is the predicate. Oh, and we also need to add 1. So here, I guess we can map this option. This is a bit ugly, but let's see. This would be the position. We can say position plus 1 and all of this as U32. So it's not, but it stops complaining, and then the sum, because we are getting U sizes, let's also get U32, which is the same type as the answer, as the first answer, which is nice. Does this work? So we are getting the digits on every possible position in the string. This is a bit wasteful because we could also find the first and the last, but meh. But yeah, I think this would also work for tricky inputs like we had in the second sample, where we have things like this one, 8-2, where they share the t. Well, it will find the digit 8 at position 0 and then the digit 2 at this position, but that's fine. We are only going to get the first one and then the last one, which will be 3. So I think that makes sense, at least to me. Let's run and see what happens. And yeah, it does work. That's great. And we can remove all of this gunk. If I remember the shortcut to remove lines. Okay, and we have a nested filter map. That's beautiful. Okay, I much prefer this to what we had before. One last thing that I would probably want to do is, instead of calling this like answer 1 and answer 2, and give it some like domain names for these things. What was that we were calculating? Calibration document is the input, and this is the sum of all the calibration values for the trebuchet, I guess. So these are actually calibration values, and this is the sum of calibration values. We could call this calibration values sum or something, or we could yeah, this, for example, this code inside of this filter map, it's getting a bit like indented and messy, I would say. So I would like to extract at least some of these bits. Maybe this function that converts, no, sorry, this one that converts a single, like gives you back a digit based on a word number. But yeah, let's try to maybe extract this. Does this work? Yeah, nice. That actually worked better than I expected. This is a calibration value for part 1, I guess. So yeah, it receives a line, beautiful, and then we just do this computation. And this, I'm pretty sure that if I run cargo clippy, yes, it will complain. Yes, look at this. You can replace this closure with just using the, like this is an unnecessary closure. You can just say, hey, map this thing to calibration value, and that's great. And we can also probably do the same thing for calibration value on the second part, although I would probably want to move this over here just so that the extraction works nicely. Extracting the function, and this would be a calibration value, let's call it part 2. Problems, why? Cannot apply refactoring. I think I just fat thumbed the spacebar and or something, and I typed something extra. Let's try again. Okay, yeah. Calibration value part 2. Okay, yeah, I don't know what went wrong there. And let's move this function after the first calibration value. Yeah. And again, we can do the refactoring here. Just, yeah, look at that. This becomes just 2 single lines, and we can just also print answer 1 and answer 2 here. And the main function becomes, yeah, much nice. Just for each line, map it to calibration value, and then add all of those up. And answer 2 is the same, but for another calculation, for another, yeah, kind of calculation for the calibration value. That's great. This could be a constant, but yeah, whatever. I trust the optimizer. And does it make sense? So yeah, this already, like, this is nice code. I'm much more happy with this. I don't care about this kind of repetition here. It's like, okay, we could, instead of extracting this, we could extract two things to say, okay, give me the digits, yeah, I guess, and then implement part 1 and part 2 in the same way, but with a different way of extracting the digits from a line. But yeah, I think that's going to be like extra abstraction unnecessarily. This is fine, I think. It's just the extraction of two functions, but each one does a single thing, and there's a little bit of repetition between the two, but it's fine. We don't need to abstract that. The only thing that I'm considering to do here, I don't know if it will be better. Well, this position thing. Oh, I think we can do, yeah, instead of doing a map thingy, we can say, hey, this, extract into a variable, position is too long, let's call it P, and just early return here. And then P would be a number already, so it's the same as this P inside of here. So I want to extract this into here. Doesn't this work? Isn't P? Yeah, P is a U size plus 1 as U32. What? Oh, I had to say sum. Yeah, sure. Yeah, this already is a bit better without the mapping. I think I do prefer this short-circuiting and like dealing with statements and values as more like normal-looking code. Yeah. So yeah, we try to, for each character, we try to convert it to a digit, or else we do something different using these number words. Yeah, this looks much better than what we had before. So let's review all of those changes. And the first code was so nasty that, well, yeah, I sort of already know that the second code just looks much more better than the first one. We cannot even see the first code with all of this indentation in the split view, but yeah, this is much better. So I'm much more happy with this. I think I'm still getting the same answers, right? Yeah, if I remember correctly, these are the same numbers. Indeed they are. Oh, and does this still run with the sample txt, and yeah, and the second, so the first sample, yeah, was for these numeric things, and the second sample 281, yeah, that is what we expect. Okay, that is very good. Let's commit this change and say refactor day 1 solution, and yeah, just call it that. I don't want to explain what I did. Hope the code speaks for itself. All right. That is basically it. Oh, by the way, between yesterday's video and today's, I added a README to the project to sort of have an idea of, I thought a little bit of what I want to do for this year's Advent of Code, and I changed some of the things that I did for last year. So the main goal is still the same. Maybe I can view this with output. Yeah, look at that. Although I'm kind of used to reading Markdown in the source shape. So still the main goal of doing this is to have fun and learn Rust. I still want to go for having a fast execution time. I want to try maybe instead of what I did for last year, where I had each solution as a different module, all in the same executable, and they run in parallel and things like that. I want to try out having like different executables for each solution, and then just using this approach of passing the input as standard input. But I don't know, I don't have that set in stone. But if we go with that route, we can still run everything in parallel, but they will just be different processes running in parallel instead of different threads. But one important thing that I want to try this year that I wasn't trying in the previous years is to do actual like proper error propagation, and learn how to use the result type, and instead of just crashing when reading like an invalid input, handle it more properly. It's not like we can do anything very meaningful. The program will still fail, but I think it's not nice to just crash. We should just have the error and propagate it upwards, so that you can handle the error if you want to. Like maybe, oh, okay, this input failed, but maybe you give me another input, and the process doesn't crash. You can handle things more gracefully, but for that we need to use less panicking and use more of propagating results up. So that's also something that I was doing today in this video. I think there is no more unwraps here. Yeah, there is none. Using unwrap OR is fine because we are, giving it a default value when unwrapping an optional or a result type. But I think in general I want to think about, okay, what could make the program crash and avoid crashes, like handle things more gracefully. And if it's, avoid, as I said here, avoid crashes due to bad or unexpected inputs. We should propagate things up, and maybe even think about like adversarial inputs. Like generally in Advent of Code, the inputs have a very defined shape, and you don't have to care about like adversarial inputs. But for an extra challenge, I think I want to try that out and make my code like more robust, or just to learn. To program in like a more robust way, I guess, and not having something that crashes if you look at it in an incorrect way. And finally, having like in previous years, I wanted to have no external dependencies or as few as possible. In this year, I would like to use dependencies if need be, like. Maybe, as I mentioned here, if I need to use a regex, just use the regex crate or rayon for parallelism, or anyhow, which is for handling errors. Things that are considered like de facto standards in the Rust community. That's fine to use, and I want to learn those things. So that's also a goal for this year's Advent of Code. I don't know why I'm saying this in this video, but I guess that is fine. I just want to clear this out. Okay, and that's basically all that I want to do for this video. So if you have been watching, thanks for doing so, and see you later. Bye bye.